Database schemas describe the structure of our database. In the relational model, we can define that the values in certain columns have to conform to some particular data type. The data types available in SQL are strings, numbers, binary data, and date and time. So for strings, for example, we have varchar n, which can store strings up to n characters. If we need strings longer than 65,000 characters, we can use long text, which can store strings up to 4 gigabytes. We have also numbers, the usual types, bit, int, float, and so on. And we have also numeric PS. This we will use more often in this course. This is a decimal number which has p digits in total, of which s are after the dot. As binary data, we for example have blob, and to store date and time, if we just are interested in the date, we have date. If we just want to store time, we have time. We can combine the two into date time, and we have timestamp, which is similar to date time, but it stores the time by counting the number of seconds since 1970. The available data types always depend on the database management system and the supported version of SQL. So once you pick a database management system for your application, you should check which data types are available. Every data type D comes with a particular domain, which we denote by DOMD. This is the set of possible values that this data type can take. So for example, the domain of numeric 2, recall that numeric 2 are 2-digit decimal numbers, none of the digits after the comma, can take values between -99 and 99. SQL allows us to create application-specific domains as subsets of the standard data types. So for example, we can create a domain, example domain, and we can define it as numeric 20. So we basically give a different name to the existing domain numeric 20. So when is this useful? You could imagine situations where you use numeric 20 for different columns. Maybe you use it to express the age of some person, and in a different column you use it to express the number of points obtained on some exercise. And the comparison between the age and the number of points is not really meaningful. So you can use these user-specific domains to express that if two columns have the same data type, then comparisons are really meaningful. We can also use these user-specific domains to further restrict the domain. So for example, we could create an example domain that consists of 2-digit decimal numbers, and we add a check constraint that guarantees that all of the values are greater than 0. A relation schema defines the structure of a single relation. It consists of a finite sequence of attribute names, A1, A2 up to AN, and for each attribute name AI, a data type, a domain, DI. A relation schema can be written as such a tuple, where we have the attribute names, colon, their corresponding data type. Often we don't care about the data types, and we will simply write the relation schemas as we have seen before. For example, here we have a table exercises, and we define that we have attributes category, number, topic, and max points. In SQL, we can create relation schemas. For example, this SQL statement, create table exercises, creates a table exercises with the attributes category of type varchar 10, number of type numeric 20, topic of type varchar 40, and max points of type numeric 20. Relation schemas are important to understand what data is stored in the database. So we often need to communicate them from human to human. Create table statements in SQL are not the best way of communicating schemas from human to human. If the data types are not crucial, then a nice way to communicate schemas is by simply mentioning the name of the relation, the name of the table, and the name of each column. Likewise, also widely in use, we can simply sketch the table header to communicate the relation schema. A relational database schema defines the structure of a database. It consists of a finite set of relation names, R1 up to Rm, and for every relation name Ri, we have a relational schema, schema Ri. Additionally, we can define a set of integrity constraints. So a database schema is a tuple consisting of the relation names, the relation schemas for each relation name, and the integrity constraints. An example is given on this slide. We have the relation names students, exercises, and results. And for each of these relation names, we have a relation schema. We have one relation schema for students, one for exercises, one for results. And we will later see what kind of constraints we can define on this schema.